Ever wondered why a car comes to a halt when brakes are applied, or why the coffee in your cup spills when you abruptly stop walking? These everyday phenomena are governed by a principle so fundamental yet so subtle that we often overlook it. It's called inertia, the unseen force that keeps your world in motion or at rest depending on the situation. Intrigued? You should be, because this principle forms the very core of Newton's first law of motion. Well, the answer lies in Newton's first law of motion. Newton's first law of motion, often referred to as the law of inertia, states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction, unless acted upon by an unbalanced force. Let's break this down, starting with objects at rest. Picture a book on a table. It's not going anywhere, right? That's because there are no unbalanced forces acting upon it. The force of gravity pulling it down is perfectly balanced by the support of the table pushing it up. So, according to Newton's first law, that book will stay right where it is until something comes along to disrupt that balance of forces. Now let's consider objects in motion. Imagine you're kicking a soccer ball. Once you've given that ball a good whack, it's going to keep moving in the direction you kicked it, at the speed you kicked it, unless something else interferes. That something else could be friction from the grass, air resistance, or maybe another player stopping it. Again, Newton's first law is at work here. The soccer ball, once in motion, wants to stay in motion, but what about the role of unbalanced forces? Well, these are the game changers. They're the reason the book won't sit on the table indefinitely if someone decides to give it a push, and they're the reason the soccer ball won't roll on forever. Unbalanced forces are any forces that aren't perfectly offset by another force. They might speed things up, slow them down, or change their direction. But the key point is, without them, objects in motion would stay in motion, and objects at rest would stay at rest. So in essence, this law is all about resistance to changes in motion. It's about the stubbornness of objects, their desire to keep doing what they're doing until something makes them do otherwise. It's a fundamental concept that underpins our understanding of how the universe works. Think about a book on your desk. It's at rest, but why does it stay that way? Well, that's because of Newton's first law of motion, or as it's often called, the law of inertia. This law tells us that an object at rest tends to stay at rest, and an object in motion tends to stay in motion, all unless acted upon by an external force. So let's delve a little deeper into the first part of this law, objects at rest. What exactly does it mean when we say an object at rest tends to stay at rest? Imagine a soccer ball on a field. It's just sitting there, right? Not moving, it's at rest. However, the ball doesn't move until a player comes along and kicks it, exerting a force on the ball. This is the essence of the concept. The ball, an object at rest, will continue to stay at rest until a force, in this case the kick from the player, acts upon it. But it's not just about soccer balls. This applies to anything and everything. The book on your desk, the parked car on your street, the coffee mug on your table, they all remain at rest because no external force is acting upon them. Now, you might be wondering, what about gravity? Isn't that a force too? Yes, it is. But remember, we're talking about horizontal motion here. Vertically, the force of gravity is balanced by the support of the surface the object is resting on. And what about air resistance or friction? Well, in our everyday life, these forces are usually not strong enough to move objects at rest. But in a frictionless environment, even the slightest push can set an object in motion. So, in essence, an object at rest stays at rest because there's no unbalanced force acting on it to change its state. A force, whether it's a kick, a push, or a pull, is needed to disrupt the state of rest. So a force is needed to change the state of rest of an object. Imagine throwing a ball in space. What happens? It keeps moving, right? This is a perfect example of an object in motion, and it beautifully illustrates Newton's first law. Just as the ball in space continues to move, all objects in motion will stay in motion unless acted upon by an external force. Now let's bring this concept down to earth. Picture yourself riding a bicycle on a smooth road. You're pedaling at a steady pace and everything feels easy. Suddenly, you stop pedaling. What happens? Your bicycle slowly comes to a halt. Why? It's because of the friction between the tires and the road, which acts as an external force. Without it, and you would keep moving indefinitely. This principle applies to everything around us, from the cars on the highways to the birds soaring in the sky, from the planets orbiting the sun to the electrons spinning around a nucleus. Everything that moves has some kind of force acting upon it, either keeping it moving or bringing it to a stop. Consider another example, a hockey puck sliding across the ice. If the ice were perfectly frictionless, the puck would slide forever. However, even ice has some friction, and so the puck eventually comes to a stop. This is the external force at play. If we were to remove all these external forces, every object in motion would continue moving at the same speed and in the same direction forever. This concept is known as inertia, and it's a fundamental aspect of Newton's first law. So in the grand scheme of things, motion is the natural state of objects. It's the forces around us, gravity, friction, air resistance, and so on, that change this state and affect the way things move. To conclude, Newton's first law of motion tells us that an object in motion tends to stay in motion with the same speed and in the same direction unless acted upon by an unbalanced force. So, without an unbalanced force, an object in motion continues to move in the same direction at the same speed. What is this unbalanced force that we keep talking about? Well, let's delve into that. In the world of physics, forces are either balanced or unbalanced. Balanced forces are those that keep an object in a state of rest or moving at a constant speed in a straight line. They are equal in size and opposite in direction, cancelling each other out. Unbalanced forces, on the other hand, are a completely different story. They occur when forces acting on an object are not equal and opposite. This imbalance generates a net force, causing the object to change its state of motion. This could mean starting to move, stopping, or changing direction. Imagine you're playing a game of tug-of-war. If both teams pull with the same amount of force, the rope stays in the middle, stationary. The forces are balanced. But if one team pulls harder, the rope moves in their direction. The forces are unbalanced and the stronger force wins. That's the essence of unbalanced forces. Now, what happens when an unbalanced force acts on a moving object? It can either speed up, slow down, or alter its course. Take a soccer ball being kicked, for instance. The ball is initially at rest. The kick is an unbalanced force that sets the ball in motion. The stronger the kick, the faster the ball moves. But what if the ball is already in motion and it gets kicked again? The second kick, another unbalanced force, can speed up the ball, slow it down, or even change its direction completely. So when you're watching a car accelerate down a highway, a baseball being hit out of the park, or even a rocket launching into space, remember, it's all about unbalanced forces. They are the invisible hands that shape the motion in our universe, turning the gears of Newton's first law. And that's the role of unbalanced forces. They are the catalysts, the change agents that disrupt equilibrium and set things in motion. So an unbalanced force is what causes a change in an object's state of motion. Let's take a moment to summarize what we've learned about Newton's first law. This law, also known as the law of inertia, is a fundamental principle of physics that governs the motion of objects. It tells us that an object will keep doing what it's already doing unless acted upon by an unbalanced force. In simpler terms, if an object is at rest, it will stay at rest. And if it's in motion, it will continue moving at a constant velocity in a straight line unless something causes it to do otherwise. We delved into objects at rest, understanding that they're not merely lazy or uninterested in moving. They're simply obeying the law of inertia, waiting patiently for an unbalanced force to shake things up. Then we moved on to objects in motion, realizing that they don't just randomly slow down or change direction. They move in a straight line at a constant speed, unless an external unbalanced force steps in. We also learned about the role of unbalanced forces, those intriguing game changers that can disrupt an object's state of rest or constant motion. These forces are the reason why the world around us isn't just a still life painting or a perpetual motion machine. And that, my friends, is the incredible world of Newton's first law of motion.